The overall goal of the preparative co-condensation technique is to access novel reagents based on molecules that are unattainable from classical synthetic procedures, which opens the door to new fields in chemistry.
The main advantage of this method is that highly reactive reagents are obtained and subsequent reactions can be done at low temperature, which is important for the synthesis of metastable metalloid clusters. This method can help to answer key questions in the field of nanotechnology, as structure property relations might be established from structurally well-characterized metalloid cluster compounds.
Though the metastable tin halide solution gives access to nanoscale cluster, it might also be used for coordination or redox chemistry or for the synthesis of novel materials. Visual demonstration of this method is critical as the construction steps are difficult to learn due to the high complexity of the co-condensation apparatus.
First, fill 5 reaction chambers with 6 grams of elemental tin. Stack the reaction chambers over a terminal ring, each of them twisted by 30 degrees, and fix the stack with a 0.7 mm graphite rod. Insert the stack into a hollow graphite tube so that the holes of the terminal ring fit with the holes in the graphite tube. Fix the setup with a second 0.7 mm graphite rod. Then, weigh the whole setup with a scale and note the value to determine the amount of tin consumed during the reaction.